So hello friends, last couple of weeks we were into continuous lecture sessions, and now again current electricity NCERT, and this is solved example. And already in that direction we have covered one video in which we had current electricity 3.1 solved example. Now we'll have 3.5, and that previous video link I'll be sharing in my video so that you could go through that also. So here comes 3.5. What is given in this problem? We would be needing Kirchhoff's law, and for that already in theory we have covered Kirchhoff's law, how to tackle Kirchhoff's junction rule and Kirchhoff's voltage law, both the laws. How do we this? You can go through from my current electricity 05. Now in this question, this is 10 volt battery. This is source of current in this complex network having the size of Q. That means this complex network is given in the form of Q, which has 4, 8 and 4, 12. All 12 edges has equal resistances. Say it would be R, and here it is given 1 ohm, and all the 12 edges, that means all 12 edges are 12 resistors of 1 ohm each. Now we have to find the equivalent resistance of the network such that equivalent resistance between diagonally opposite ends. So here in the diagram, as question depicts, equivalent resistance between A and C dash. These are two diagonally opposite points. Firstly, here the point, first and foremost point we need to understand is we are to take, that means consider, assume 3I of current. Battery is sending 3I at the junction A, and such that I, that means it is splitting in equal proportions in all the three directions, that is I, and I. Why? What's the reason behind this kind of assumption? Because the given circuit is symmetrical, and from all the route, whichever route current decides to proceed, it will have to cover shortest three edges. Say this, and this. Second route, this, and this. Then third route, this, and this. Then this. That means any route we follow, we'll have to cover three edges. That means potential is equally distributed for all the three routes. That's why here in the given situation, equal division. So hence current I, and further I will be splitting into I by 2, and this I also I by 2, and this I also I by 2 and I by 2. Then in next stage, all I by 2 will be combining into C. This I by 2 and this I by 2 will be combined to form I. Then this I by 2 and this I by 2 will be combining to form I, and this I by 2 and this I by 2 again will be combining to form I. So hence all these three I, and I will be combining to reform 3I, which is going back to back. Hence this is a rational assumption of currents across all the edges and routes. Now how do we apply Kirchhoff's law? So this was from symmetry after considering of all the currents in each of the edges across all the resistors. Let us consider one closed loop here in the circuit. Let us first decide A, B, C dash, E, A. This closed loop, I'm applying one different color across this. So this closed loop already I have pointed out. I'm not going to discuss how to apply Kirchhoff's law. I have chosen the closed loop. Now directly I am to apply, because already I have explained how to apply Kirchhoff's laws in detail in my theory lecture notes. So this closed loop, A, B, C, C dash, E, A. And in brief, let me remind, for closed loop, we apply the technique sigma IR is equal to sigma E. So all IR sum IR plus I by 2R plus IR is equal to 10. And let us recall again what we are to find. We are to find the equivalent resistance between A and C dash to find R equivalent, that is R A C dash. This we are to find, and this has become, it implies that 1 IR, 2 IR, 2 plus 1.5. That means 5 by 2. 5 by 2 R is equal to 10. Let us consider E only. This is equation number 1. And also across these 2 points A and C dash, E is also equal to IR. Also across the points A, C dash, E is equal to main potential is equal to main current. Main current, that means 3I. Already we are considering main current as 3I. So 3I, here also 3I multiplied by required equivalent resistance R A C dash. And this has become equation number 2 from equation 1 and 2. 5 by 2 IR is equal to PI into, now what do we cancel? It implies that RAC dash is equal to 5 by 6R. So we can generalize also. Now as far as the answer is concerned, here in the given question, capital R was given 1 ohm. You can see here each of resistance 1. So capital R is given. Therefore, RAC dash is equal to 5 by 6 into 1. That means 5 by 6 ohm. So hence it is done. Now, as we can see here in the question, determine the equivalent resistance of the network, and second part, the current along each edge of the cube. That means if we consider now already from equation number 2 or from equation number 1 also, we can find if we use 5 by 2 I, this R is given 1 and this E is given 10. So I could be found. And here across some of the edges, I by 2 current is also going. That means whatever value of I we will be obtaining for these edges AD and AA dash and AD, and this was and AB. Across these 3 edges I, otherwise this, and this. All these are I by 2, and again lastly this, and these 3 edges will have a current of I. So let's first find the I. Now from equation number 1, second part from equation number 1, 5 by 2 IR is equal to E. 5 by 2 IR is equal to E. 5 by 2 I into 1 is equal to 10. It implies that I is equal to 4 ampere. Hence, I'll be listing all the edges. Hence, following are the list of edges along with their currents. Now I'll be naming edges A, A dash, AD, AB. Then lastly, these were the 3, and D dash, C dash, B dash, C dash, and C, C dash. All these are having I, that means 4 ampere. 3, 4, 5, 6. Now remaining edges. Now again I'll be listing concern edges which has got I by 2. A dash, D dash, A dash, B dash, D, D dash, DC, then B, B dash. All these 6 edges has a current of I by 2, that means 2 ampere. So determine the current in each branch of the network shown. Again, this diagram is given in the question. Sometimes in the given diagram, current is not shown. In that case, we need to assume from our side what are the currents. But here it is more feasible to use. Now directly we don't have to judge anything or anticipate. Directly we are to start writing the equations of decided closed loops, and wherever we need, let us see, this is I1, this is I2, and this is I1 minus I2. That means junction rule. From junction rule, incoming current is equal to outgoing current. So here it is not appearing proper to use junction rule because directly currents are shown. Here this, these, this and this, I2 plus I3. Again directly junction rule is applied while assuming currents, so no need to apply again. That means directly we need to decide the closed loops A, T, C, A. This closed loop we have to decide first, and here only applying Kirchhoff's second rule on the closed loop A, B, C, A. A, B, C, A. 4 into I1 minus I2. Traversing circuit in opposite direction with respect to current. So negative. Minus 2 into I2 plus I3 minus I1. Now again along the direction of current. So 1 into I1 plus 1 to I1 is equal to 10 volt. 4 I1 minus 4 I2. This is equation number 1. Considering closed loop A, B, C, A. Now this time this closed loop. How many unknown variables are there? I1, I2 and I3. And what is to be found? Determine the current in each branch of the network. And for this purpose, we need to find I1, I2 and I3 first. Then only we could find all the branches currents, because all these currents are expressed in the form of I1, I2, I3 only. This time A, B, C, A. 4 I2, then plus 2 I2 plus I3 plus 1 I1 is equal to 10. It implies that I1 plus 6 I2 plus 2 I3 is equal to 10. This has become equation number 2. Equation number 1, 2. Now third equation, this one, B, C, D, E, B, like this. For 3 unknown variables, at least we would be needing 3 linear equations. Simple law of algebra. Now for this closed loop, again I'll be writing closed loop B, C, D, E, B. Keep checking from the diagram. 2 into I2 plus I3. All these are coming positive because we are traversing our circuit along the direction of current. Otherwise, we would be having negative. This is not a rule. This is our convention. It is up to you which convention you follow. But I suggest you simply apply this only. Plus 2 into I2 plus I3 minus I1, that is equal to 5. Just now we saw equation number 1 and 2. Then after that, closed loop BCDEB. I'll show you the initially equation number 1 was ADCA. This is the equation number 1 which we obtained this. Now ABCA, ABCA. From here we get equation number 2, this one. Now from the loop BCDEB, this loop. Now let's see what do we get. 2I2 plus I3 plus 2I2 plus I3 minus I1, that is equal to 5. Okay, it implies that, let's see, minus 2I1, 2I2, 2I2 plus 4I2, 2I3 and 2I3 again plus 4I3 is equal to 5. Now third equation, this has become third equation. Clearly visible from equation 1 and 2 if we add up these two equations. Now adding equation 1 plus 2, we get simply 7 plus 1, 8I1 equals 20, 4 to the 4, 5 row. I1 is equal to 5 by 2 equals 2.5 ampere. One value now we have got. Now remaining I2, for I2 and I3, what do we? Let's do one thing. Multiplying by 2, if we multiply equation number 2 by 2, then here we obtain 4I3 and here 4I3. So then we can subtract, and in the process of subtracting, this I3 will cancel out and only an I1 value already we have got, that is 2.5, and this way I2 could be found. Now equation number 2 multiplied by 2, we have 2I1 plus 12I2 plus 4I3 is equal to, and then equation number 3 minus 2I1 plus 4I2 plus 4I3. Now subtracting these two, cancel, then 4I1 plus 8I2 is equal to 15. But I1 value already we have, that is 2.5. This is 2.5 into 4, that is 10. 8 I2 is 15 minus 10 is equal to 5. It implies that I2 is 5 by 8. Let's check. Yeah, is correct. I2 is also done. And hence from any of the values, simply these two values could be substituted in equation number 1 or any equation, whichever you like. Then from equation number 1, so let's pick equation number 3. Equation number 3, minus 2I1 plus 4I2 plus 4I3. 4I2 plus 4I3 is equal to 5. Now let's put the values. For I1 we'll put 2.5. For I1 we'll put 2.5. For I2 5 by 8. It implies that minus 5 plus 5 by 2 plus 4I3 is equal to 5. 15 by 8. This way, after obtaining these three values, I1, I2 and I3, we have got all the three values for all the branches current. It was determine the current in each branch of the network shown in figure. I1 was 2.5 ampere and I2 was 5 by 8. Hence, all the branches AB, that is I2 5 by 8 ampere, AC I1 5 by 2 ampere, AD I1 minus I2 5 by 2 5 by 8 5 the 40 minus BD is I2 plus I3 5 by 8 plus 15 by 8. 1 plus 3 4 4 5 are 20 by 8 4 5 are 24. BD is I2 plus I3 5 by 8 plus 15 by 8 20 by 8 5 by 2 ampere. Then CD I2 plus I3 minus I1 5 by 2 minus, oh, it should be 0. DED, yeah. Last branch, it is I3. I3 is 15 by 8. After getting these three values, I1, I2, I3, I have arranged all the branches currents. So hence this question is done. Here comes example 3.7. NCERT solved current electricity. This is Wheatstone bridge unbalanced. It is not balanced Wheatstone bridge. So we need to apply Kirchhoff's law. We are supposed to find the current IG in this branch, provided 10 volt of battery is connected across these 2 points A and C. That means 10 volt is maintained across AC. So let's consider A, B, D, A closed loop, then thereafter B, C, D, B. These two closed loops we'll be considering for Kirchhoff's law purpose. BADB is equal to 0, equation number 1. Then considering closed loop BCDB. Then in this loop 10 I1 minus IG. 10 I1 minus IG minus 5 I2 plus IG minus, this has become equation number 2. Now this time closed loop A, D, C, E, A, C, E, A. And this is our equation number 3. So let us first try to eliminate I2 from equation number 3 so that we could find IG from equation 1 and 2. From equation 1 and 2, let's try to eliminate I1. For this, we need to multiply equation number 2 by 10 so that in equation number 2 also we get 20 I1, and already 20 I1 we have in equation number 1 also. So then subtracting both the equation, then multiplying equation number 2 by 10. So 20 I1 minus 10 I2 minus 12 I2 plus 3 IG is equal to 0. Now we need to subtract. By subtracting, we obtain, it implies that I2 is equal to, and this is equation number 4. Then equation number, from equation number 3 and 4, 13 I2 plus IG is equal to 2. Now we are to 409.5 plus 1. Therefore, IG is 2 upon 410.5. It implies that IG is 4.87 milliampere. Hence done. So we have got the answer which was given in NCERT solved example, and this way we have finished all the solved examples NCERT current electricity 12th CBSE. So thanks for enjoying, all of you my physics loving friends, and keep waiting for another videos. Until then, bye, take care.